We should all patch our software all the time. And therefore, it's really good to have a patching server in your environment, a WSUS server. Because that's the good guy. He's going to help you. He's going to make all your servers be happy and updated and everything. Until it turns to the dark side. Welcome to Threat Talks. My name is Jan Koning, and here from headquarters at Ontoit, we bring you the next episode. And we're talking about a nasty vulnerability in the WSUS server. Let's get onto it. Welcome to Threat Talks. Let's delve deep into the dynamic world of cybersecurity. Let me introduce my two guests of today. It's Rob Maas, a friend of the show, and Luca Cipriano, also a friend of the show, of course. And the background of Rob is blue, which gives away a little bit that he's going to tell us how we are going to avoid everything that Luca is actually going to make us afraid of. Correct, gentlemen?
Yeah, correct.
Yes,
indeed.
So I said the WSUS server because I don't know how to pronounce it actually. Rob, do you know?
It's Windows Server Update Services. And that's as far as I can get.
Okay. So I'm not alone. Okay. Could you explain what the WSUS server is for and what it does?
So like what the name suggests, it's an update server. And it's used in the network for other Windows servers to get their updates from. So instead of managing all Windows server individually by getting new updates, you have this central server, or maybe you have multiple, where the server can request the updates that are applicable to that server. So it helps you a lot with keeping servers up to date and patched.
Was this a remnant of the past in which the bandwidth was limited and we had to be careful about it?
Also, but it also means that you can, if you're talking about zero trust and protect services, it also means that your Windows servers don't need any external access, in most cases, to get updates. And they just go to this Windows Update server.
Yeah, and there's also, you can also schedule updates here. Huh? I mean, you can
make
control.
You can make groups of servers and then decide what updates they should get, which one maybe not, because they might break something. So you're really in control of your updates and which server gets what.
You pilot servers first instead of everything at the same time, and then have a CrowdStrike-like incident where your servers keep rebooting. Yeah, okay, clear. So, and it's in the middle of the environment, huh? Because how does it work? How get updates pushed? Do all
the servers need to connect to the Windows Update servers, and the Windows Update server, of course, needs to have external access to retrieve the updates. That's
So in terms of firewall, that server has availability to connect to Microsoft to get the updates locally cached, and then all machines that run Windows,
should be
for
able
example,
to
all
connect,
laptops, and all insert domain controllers, etc. They should be able to connect to the
Windows Update server.
And I'm afraid that Luca is going to tell us that web service that it runs is actually broken. Luca.
Yes, so there is a vulnerability in this server, which leads to remote code execution. Thing is, the attacker does not need to be authenticated, so anybody that can reach the server can exploit this vulnerability. And of course, you might ask, I mean, it should not be open to internet, right? But apparently, a lot of companies, they have it exposed to internet, which of course expanded the attack surface for this attack. But of course, an attacker.
That actually means that that without authentication, you can simply send a packet to this server that's exposed to the internet, and then you're.
Yes, that shouldn't be exposed to internet, but it is in a lot of cases.
But even if it's not exposed,
if it's already inside,
it is exposed to all your Windows machines. So it's just one step extra, which we know is not that difficult.
No, exactly. And as Rob also mentioned before, this is something that your hosts need to communicate to retrieve the updates. So in general, there's traffic that you see coming and going. So it also blends in.
It must be a very sophisticated attack then.
Yeah. No, there are a couple of things here. So the first thing is, so the attacker needs to send a request, a SOAP request for authentication, where it needs to send the request to a get cookie function. So the function that it gets the cookie and it adds it to the SOAP request.
So it's a HTTP call with a cookie attached to it. That's what it looks like if you see the attack coming in.
So this can be exploited in two ways. First of all, the encryption key is hard coded in the server. So I mean, it's an hard coded key, so it's easy to encrypt. But also, you could slip in the payload within a legitimate back and forward during the authentication process. The vulnerability stems from the fact that this server used an insecure.net function to deserialize the content of the traffic, which is the binary formatted .deserialize.
Yeah. So
function.
check if I understand what you're saying. So the attacker sends a encrypted payload, like a byte in a header of a regular web request.
Yes.
It needs to be encrypted, but with a key that is publicly available because it's in the DLL or whatever it is, right? So
This
it's
is
easy
hard-coded,
to. What you're saying is it's easy to make it once you know that secret.
Yes.
And that's not all that hard.
Yes.
So then you send it to a certain endpoint, API endpoint on the server, and that is going to do deserialize.
Yes.
And that's where the things break.
Exactly. So
I really wonder how, because
yeah,
deserialize doesn't seem like, because what is this deserialize?
So in general, like serialization is when you transform data into byte stream and it's used to be stored or transported, and the other way around, when you deserialize, you transform the byte streams and you rebuild the object.
Yeah, so this function gets an encrypted cookie, like a byte that nobody understands, not even computers.
Yes.
And then the deserialization makes it into this URL, this date, timestamp, this whatever.
Exactly, in the format that it should be the object. So what the attacker does, it generates a payload using chaining several gadgets, and basically when they get deserialized, this function is insecure, and the server treats all the traffic as if it's okay, and it will trust it. And then this chain of gadgets will lead to remote code execution in the OS.
I don't understand this. I mean, you send data, it's deserialized. That is just decoding packets and putting it somewhere in memory, right? How can you then? Is this a buffer overflow then?
No, it's not a buffer overflow. It's just like that it is an insecure function, and chaining this gadget can lead to unexpected behavior, and one of these is executing code at the OS system.
Rob, would firing the developer be the solution here? Because it really sounds like a very basic thing that you need to implement.
I have no idea why it's there, and also I'm not working at Microsoft, so I can only make educated guesses.
You cannot solve it for us.
But I cannot solve this, no.
Okay, it surprises me. It sounds like a really big flaw in a very simple function to me, right? We've seen many of those, of course, but in a security product, that worries me. That's why I'm
indeed, yeah. But I mean, it's not the first or the last time that we've seen this kind of
but in such a powerful server, okay. So we have you send a blob that's easy to construct. Once you understand it's easy for people to replicate, and then remote execution. So there's actual software of the attacker running on the WSUS server.
Yes, indeed.
Great.
So we have seen this exploited in the wild.
But first want to have some more comfort on
how
we can prevent all this. I want to certainly know how it's actually working.
Yes,
how it's in a minute. Rob, what can we do here? Because
on the deserialization, not much. Except that there is a patch available, so you can patch your server. That's one thing you can do.
You already have your patching server.
Yeah, you should patch your patching server. Yeah. The other thing is look for processes that should not be there. If you have an EDR tool or XDR tool, then you can hopefully spot the abnormal behavior. Also, if these processes, they will be started by one of the processes that the Windows Update server runs. So it will be a child process. That's also something you can look out for, because that should not be started by those processes. So you have a few things that you can check on. If your server is not patched.
Some endpoint protection solution.
I would definitely start there. Yeah.
And what about the network? Because Lucas said, "Hey, it's available. it's publicly available from the internet." Is there a use case for that? Why would your remote machines maybe?
I would say not. Because especially, there's no authentication involved. So I would, even if you need to patch remote machines, then there are plenty of solutions like SASE or VPNs, or nowadays modern solutions like WireGuard or Tailscale. You have so many solutions to securely connect to your network and make it part of your, let's say, internal network. You don't have to expose this to the internet.
Yeah, there's very little things that you should expose, except for the VPN endpoint. Right? And we've seen problems in those equipment as well, but that's a different episode.
Yes.
We have recordings of that.
Yeah, indeed.
Okay, so from the internet, there's really no good excuse to do so. If you want to update your remote machines, if they are there for weeks, then what you do is indeed do SASE or VPN, as you said. So that you should
Plenty
really
of
do it
solutions
anyway.
there.
So yeah, clear. And internal, I mean, is there a way, because he says it's an API endpoint
Internal is get a bit harder because these ports needs to be open. So the endpoints, at least the Windows endpoints. So what you can do, for example, is make sure that you have proper network segments or protect services. And then if there are Windows servers in those, then only allow these servers to communicate. That will limit it a bit. But if you are really a Microsoft house, then you probably will end up with a lot of Windows machines that need to talk to that server. So they will be there. What you can do, but it will be limited, is do it on application detection, content inspection, that at least if it does not comply with the standards, that at least you can detect something. But I think for this particular attack, you must rely on the endpoint, unfortunately.
Yeah, and in this particular one, we can actually install the patch now, of course.
Yeah, that's.
But if it's a very similar thing,
of course, yeah.
Then endpoint protection on your server. Okay. Luca, you said it's not just in theory. It's actually being exploited. What are who and how?
Yeah. So we have seen that there was a report from the ASEC, a company that was performing an investigation about this exploit, and they found out that it was used to deploy a well-known backdoor, which is called ShadowPad. And it's a backdoor that is mostly widely used by Chinese APTs. So they managed to use this vulnerability to get within the company, within the target, I mean. So the way they did it, they managed to execute remote code. And what they have done, they have used PowerCat. PowerCat is a tool like Netcat, something that is used to for remote communication, which runs in PowerShell. You can use it as in PowerShell, so it runs in memory. They don't have to bring a binary, and they used invoke expression, which is a function that it is a PowerShell command that you can use to run something from remote, for example, in this case, PowerCat, the PowerShell script, and load it directly in memory without bringing the binary to the host, but they just run
So
it
they
there.
do need an extra binary in order
They
to do
don't need
this?
an extra binary. They just run the remote code execution, and they with IX, they say, okay, execute this, which is located at HTTP, wherever I host my malicious code.
But they have to. They will download it, but it's not on the disk.
It's not on disk.
It's just
yes,
in memory.
It's just in memory.
Yeah. So
exactly.
you're living off the land tools to run it.
Yes.
And the script itself,
correct.
of course, is malicious.
Yeah.
Okay.
That's correct. And that, of course, it gives you already like a reverse shell, or anyway, some tools that you can use. And from there, they use it to then install this ShadowPad.
Mm-hmm. Is this required? I mean, it is common. It's good to understand that there's always multiple steps involved in order to actually get to the keys of the kingdom, right?
Mm-hmm.
I mean, if you can run arbitrary code, why don't they execute these tools immediately then?
In general, of course, I mean, you need
I'm sure that Rob is going to say, haha, now I got you. Because I can actually download, detect the download of this script, right?
Yeah.
Right or not?
Yeah, if you have a good EDR tool, because it is in memory, we should be able to spot the execution of PowerShell by one of the Windows Update server processes. What is loaded in memory, that's really up to the EDR tool to scan. So you should have a proper
but
EDR tool.
it also traverses the network.
Yeah, the outbound network connections you can also, of course, block. You should only allow connection, in this case, to Microsoft Windows updates. But if it is full open, what's unfortunately quite common, then the attacker might be able to use the same port, because port filtering we often see, but specific on full qualified domain names we not see. We do not see. So probably the server has access to go to the internet on port 443 to get the updates, but they don't have not made it so specific that it only can retrieve updates, but also connect, for example, to Lucas.
So that would be
server.
a mitigation. Make sure that the server, of course, again, endpoint, but also make sure that the server cannot download the second stage.
Correct. Yeah.
And why? But why is there a second stage then still? Because why? I mean, if you can push arbitrary code, why don't they do that immediately?
Well, of course, in
or
a
are
lot
they
of
just lazy?
in a lot of attacks we have seen that happen also in the past. I think we discussed it also. The Barracuda, like attackers or APTs in general, they like to have multiple backdoor that are in several places, because in case they get detected, one can just slip out. So I mentioned the Barracuda because they managed to put a backdoor that was in the database that nobody saw. So even after then restoring everything, they could have access anyway. So in general, they search, they look for having more.
You need some kind of persistence step.
Yes, some kind of persistence that makes sure that you don't have to. Also, because after you patch it, if I don't have like a backdoor, then I mean you close the door, I can't enter anymore because you patch your vulnerability.
It's a longer term effort, but in the short term you could probably do something nasty already.
Yeah, and this kind of backdoor, especially for example, this one they provide additional functionalities that they might, for example, help exfiltrate data in a more stealthy way, or they use so I mean where PowerCat only does not have all that, they use also different ways. So also one of the things that they have done, they have of course downloaded this backdoor and they used it with using DLL side loading. And this kind of attacks often they can also pass through EDR detection sometimes.
What is DLL side loading?
So basically it means that as an example, I can bring within the system an executable that is a legitimate executable. I've done in the past a proof of concept with VLC. So I bring VLC, the player, that is just a normal player. And then I craft a malicious DLL, a malicious library, which has the same functions of the legitimate libraries that VLC uses, but plus has malicious functions.
That's a kind of DLL proxy then. And,
it's a DLL.
Everybody uses the proxy instead of the real thing.
Yes, exactly. You use like a proxy. So my calls then are for the legitimate calls are forwarded to the legitimate DLL. Which maybe has another name, but then the one that should be the legitimate is actually the malicious. And in this way, when the executable is run, then the malware is loaded in memory, and then you can use the commands.
That's what they also did.
Yeah, sorry?
That's what they also did here.
Yes, indeed. They use the DLL side loading to load it. And this, unfortunately, sometimes can also pass through EDR solutions.
Doesn't work, your EDI solution.
It depends on the EDR solution. And also if the file is detected when it's being downloaded. So there are already a lot of ifs. And again here, what's going to be executed with this DLL, that should be caught by the EDR, because that should be abnormal behavior for the system. Yeah. So maybe the loading goes well, then you already have a step further, but then still what does it execute might trigger the EDR. And if it's something that needs to go outside, then hopefully your firewall will block it.
Okay. And then?
And then at that point, once the attackers are in, of course,
they can do anything.
And also like you are in a server that normally communicates with the host in your network. So the traffic can blend in, and what we've seen also, the attacker, they use like leaving off the lands in general to perform action. So it try to blend in with legitimate traffic in general.
Yeah. So what you're saying, and so then the WSUS server is their stepping stone, more or less. We've already seen that it's probably well connected within the network, and their admin there, they can do whatever they like.
Yeah, because it executes codes as system. So basically, our system.
Yeah, but do we know of any real world harm that is done already? Because it's quite recent.
I mean, this what I mentioned now with PowerCat and the DLL side loading and everything. It is an actual investigation of a company that got hacked. Of course, there's no details of which company was because.
And also not what the harm done was, but you can imagine that this could be big, and especially since the first step is so easy to do, and it's so impactful.
Well, yeah, you also have like several proof of concept in various GitLab. So if you want tomorrow, you can just try and run it, and it will work.
Okay, now Rob, that brings us to our final advice. What do we need to do? All of us, everybody who has Windows, which is almost everybody.
For first, let's assume that every step was successful. And so Luca gained access to this Windows update server. Then in a proper environment, this Windows update server is isolated. It can retrieve a lot of connections because the Windows systems need to get their updates. but it should not be allowed to go outside itself. So for lateral movement, you can make it really difficult for, in this case, Luca, to see what's else in the network. So that's one step. So I think if you look at a real world scenario, make sure that the Windows Update Server is in its own segment, network segment, or protect server if you follow the zero trust wording. Make a very specific policy for inbound access only for Windows servers if you have the chance. If you have the chance, also do it application-based with content inspection. And on the server itself, run EDR or XDR, whatever you use, and make sure that the outbound connection of that server is only going to Windows Update servers and not to everything on the internet. And then I think you already have a quite okay setup. And of course, nowadays, patch the server because there's
for
a
this
patch.
particular
For this
test, we need to
particular-
patch the server. We need to do it right now.
Exactly. Yeah.
But to prevent the next similar episode from happening,
All the steps.
everything
before.
that you just said.
Yeah.
Okay.
I will say also probably setting up some alerting in a CM, for example, for usage of base64 encoded commands with PowerShell or all these kind of things can also help you detect if maybe the vulnerability is not known, but something is happening within your network. You can maybe catch it. Because in general, you should be able to know who should run some of the commands on this server using PowerShell. And
especially if the parent process is a Windows Update Server related process.
Yeah.
That should trigger something.
A bit off topic for this one maybe, but why would we allow PowerShell on so many? Isn't there a way around that you not by default install this? I mean, I know that Windows administrators love it, of course.
That is the problem. Is always.
But there's so many attacks these days that we've seen that do this, huh?
Yeah, I mean,
that use this.
PowerShell is pretty powerful, but in general, you will need a way to run commands, even if it's command.exe instead of PowerShell. There are things that you can use, like certutil. You can use it with command.exe. You don't need a PowerShell shell.
There's always another
you
tool.
always have living off the lens, and of course you have network administrator or system administrator that will need to run commands. So
they will be very miserable without it. So, so what you're saying is, those living off the land, this living off the land problem is really not going to go away.
I mean, it's abusing legitimate things that are needed for really nefarious purposes.
Okay. Fair. Thank you.
Yeah, thank you,
gentlemen. Thank you very much for these insights. We're going to patch tonight, and to our viewers, thank you as well for tuning in. And if you'd like this, we'd love your like on YouTube, on your podcast app, because it helps us spread the word further. While you're there, subscribe, because then next week you'll have our next episode in your inbox as well. Thank you. Bye bye. Thank you for listening to Threat Talks, a podcast by Onto It Cybersecurity and AMS-IX. Did you like what you heard? Do you want to learn more? Follow Threat Talks to stay up to date on the topic of cybersecurity.